Hi guys, we continue solving our task and let's check. Design quite a lot of functions, so we have to design your implementation of circular queue. The circular queue is a linear data structure in which the operations are performed based on FIFO principle, and the last position is connected back to the first position to make a circle. It is called a ring buffer. Okay. One of the benefits of the circle queue is that we can make use of the spaces in front of the queue. In a normal queue, once a queue becomes full, we cannot insert the next elements, even if there is a space in front of the queue. But using circular queue, we can use the space to store new values. All right, so we have to implement our class with some initialize the key, the object with the size of the queue to be k. Okay. Then we have front method gets front item from the queue. If queue is empty, return -n. The rear gets the last item from the queue. If the queue is empty, return -1. Then we have enqueue inserts an element into the circular queue and return true if the operation is successful. Then dequeue deletes an element from the circular queue, returns true if the operation is successful. Is empty, check for empty, is full, check if the circle is full. You must solve the problem without using the built-in queue data structure in your programming language. Okay, so let's think about test cases that we can use here. So for example, we build a queue with 3 elements, then we enqueue. So enqueue, it means insert an element, 1, 2, 3, and 4. So here we return false because the size is full. And then we have rear. So rear, it's last item from the queue and is full true, deck true. So we return, then we enqueue 4, and then rear 4. Okay. So let me think about it. So we have to design the circle queue is a linear data structure in which operation performed based on the is that we can make use of the spaces in front of the queue. Okay. But we actually initialize, right, the object with k position. Then we have front, then we have rear, inserts an element into the circular queue. Okay, then we have deck deletes an element from the circle queue. Okay, deck. So when we do a deck, so we actually should remove 1, right? So let's think about it. How can we implement? So I think that what we can use some linked list here, right? So a linked list. So we have a list of integers, right? Integer, new linked list, and in linked list we have add, we have size, and I think in linked list we have get top and get yeah. So let's see what we have. Linked list Java. Yeah, so it's double linked list. So for example, we can add an elements, right? We can add elements. we can set some position. We don't need it. We have remove function. So for example, we put it here, geeks, and then here this one, then we remove one. And after removal, okay, so it position. And then we remove iteration. Yes, we had first and get at last, right? And also get first and get last. So, so here we actually can initialize in size with, yeah, I think we can do like this. And then this list equal to new linked list with size key. And also let's have here size, max size, and this max size would be equal to key, and then NQ. So NQ is actually a list add value, and if list size, yeah, we can is full, right? Return list size equal to max size. So we can check here if is full, return false. Otherwise, we add to the list this value. Then is empty. We can just return the list is empty. I think it's already exists here. Then in DAQ we have list. Do we have remove from offer, pick, poll, first, poll, last. I think list, poll, last. And here if is empty, then we return false, poll last, and return true here as well. Prompt, we just return list get a pick first, I think. Here pick last. Okay, so let's check. Compile error, list, new linked list. Cannot infer type paragraph for. Let's try like this. Okay, we have null pointer for this use case in front. So if so here we should return -1. So if is empty, we return -1. I think here as well. Okay, so let's check this use case. So we create a queue, then we create a queue with 8 elements, and then Q3 950. Then we dequeue 3 9. We check for is empty. Rear, front, rear 9. Maybe pull first. Pick first, pull first. Yeah, so we're done. So actually here we use linked list for this problem. And let's check other solutions. Yeah, we can use 2 pointers, but here it's for linked list actually. Let's check concise Java array. Yeah, we actually also can use here an array, of course. Editorial we don't have. But yeah, actually we done, so quite, yeah. I cannot say that it's an interesting task, but we actually solved this. So yeah, that's it for today, and see you tomorrow.